Hey, sports fans, let's look at the volume of a cone. So thanks for stopping by. Today we'll look at how to compute the volume of a cone. So let's start. So like I said, today we're going to talk about the volume of a cone. So this is a cone, and it has a few different component parts that it's important to know. So the point of the cone is called vertex. This dashed line here is the altitude of the cone, or the height. If it were not a right cone, it would also be its axis. It is also its axis, but sometimes we have a slanted cone that the axis and the height are two different things. But for today, we're just going to focus on a right cone. So let me write that down. A right cone. And the reason this is called a right cone is because the radius of the cone, which is right here, this is the radius, is perpendicular to its height. So whenever we have that, we can solve a lot of the problems we're going to talk about today. So on to the next slide. Okay, so the volume of a right, I should make that a dashed line, I guess. The volume of a right circular cone. I can make a better cone than that. Is its height or altitude and its radius. It's defined by its radius. So the volume is going to be the area of the base, which is a circle. It's a right circular cylinder. So let's write that down here. Right circular cylinder. Or right circular cone. I misspoke. So it's the area of the base times the height divided by 3. This is interesting to me because this formula, just the area of the base, the circle, times the height, would be the area if this were a right circular cylinder like this. So imagine that we were taking a cone out of the middle of that cylinder. And it's exactly 1/3, which I think is very interesting. So let's look at an example. So pi r squared times h, point pi r squared times h divided by 3. Sometimes you'll see it written in a textbook as 1/3 pi r squared times h. So let's look at our first example. So for the first example here, I've drawn a cone, a right circular cone. Because this is a right angle, the height and the radius are at right angles. Or I should say the height and the base are at right angles. So we're going to use that formula, which is volume equals 1/3 pi r squared times h, or pi r squared h divided by 3. So 1/3 times pi times the radius. Well, let's see. My radius is right here, so that's a 6. So I'm just going to substitute that into my formula, and I want to remember to square it. Common mistake is to forget to square this. It's r squared, so it's 6 squared times the height. The height happens to be 8. So we're going to go ahead and substitute that. So one by one, we can simplify this. 6 times 6 is 36 times 8. And then if I finish simplifying this, I could do some quick mental arithmetic. This goes into 36 12 times, and 12 times 8, well, that's 96. So that equals 96 pi cubic feet. The reason it's cubic feet is because our original dimensions are in feet. So this is the volume, so it's how much volume or how much space this cone would take up. So 96 pi feet squared. Now, that's the exact answer. In many textbooks, you'll see them say to use 3.14 as an approximation for pi. So you'd have 96 times 3.14, which would make this about, that's why I have to switch my equal sign to an about sign. That would be about 301.44 cubic feet. And the reason we often do this is this isn't very meaningful to most people. 96 pi cubic feet. It's the exact answer, but most people want to know, well, how many cubic feet is that? Well, it's about 301.44 cubic feet, and that's to the nearest hundredth. So that's why oftentimes you will see this. So here's a problem that introduces something new, the slant height. So the slant height of a cone, misspoke, said pyramid, same thing. This distance that I'm tracing right here is the slant height. And this distance, the radius, is also given. So I have a slant height of 5 centimeters and a radius of 3 centimeters. But can I find the volume yet? The answer is no, I don't know what the height is. So I have to figure out what the height of this triangle is. Well, the triangle that's superimposed on the inside. So the height squared plus the radius squared is going to equal the slant height squared. And they call the slant height L. Well, different texts call it different things. So I can either recognize that this is a 3, 4, 5 triangle, or I can go ahead and, run the numbers here. So h squared plus 3 squared equals 5 squared, which leaves me with 25 minus 9. So h squared is equal to 16. And if we take the square root of each side, we find out that this is indeed 4 centimeters. So now that I know the height, I can go ahead and figure out what the volume of this cone is. So the volume, again, remember, is 1/3 times the area of the base, which is pi r squared because it's a circle, times the height. So 1/3 pi, the radius was given as 2. The height we figured out was 4. So I can go ahead and say, all right, 1/3 pi times 9 times 4. Oh, look at this. 3 goes into 9 3 times. So that just leaves me quite simply with a 12 pi. And again, do we know what 12 pi really means? It's 12 pi cubic centimeters. We don't really know what that means, so oftentimes we will go ahead and substitute 3.14 in place of pi and say this is approximately 37.68 centimeters cubed, cubic centimeters. So that would be our final answer.
Hope you like those volume of the cone problems. Won't you please like, subscribe, comment, and share? I would very much appreciate it. And as always, don't forget, math is not a spectator sport. The only way to learn math is to do math.